Good morning. My name is Peter Cohen. I'm a technology editor at RCR Wireless News. And joining me today to talk about market expectations for low latency services is Mr. Prakash Sangam, the founder and principal of Tantra Analyst. Prakash, good morning.
Good morning, Peter.
Thank you very much for joining us. Very interested in just diving right in today and helping you give us a sense of what the MEC market looks like right now and where you think it's going.
Perfect. Good morning. Hello, everyone. Good morning, afternoon, or evening, depending on where you are. Thank you, Peter, for the introduction. As Peter mentioned, I'm the founder and principal at Tantra Analyst. We are a boutique industry analyst and a consulting and advisory firm focused on 5G, AI, cloud, and few other things. I personally have more than 20 years of experience working for AT&T, Ericsson, and Qualcomm before starting my own venture. I host a podcast called Tantra's Mantra. I write for Forbes, RCR, Fierce Wireless, and few other publications. And I am also a member of 3GPP, so I know a thing or two about standardization as well. So let's dive into this subject. For the next 15 minutes or so, I'll talk about mobile edge, some of the market overview, and what are some of the trends, and so on. Right. So let's get to some basics. So how do you define edge? What is edge? Actually, when you talk to people, you hear a couple of different definitions and how they define it, depending on the business they are in, depending on the business they are trying to target, and so on. I think the picture I have on the left-hand side kind of clarifies what it is, at least from my point of view. And frankly, a lot of the industry is zeroing in on this kind of definition. So if you look at cloud computing, it is straight and simple client, server kind of architecture. You have cloud where most of the value is created and distributed, and then devices which kind of generate a lot of the data that is needed to create at the value. So you basically create a lot of data, haul it all to cloud, do the processing there, create the value there, and maybe send it back to devices or some other kind of medium. What edge computing does is it brings in a middle layer. Some might call it edge computing platform. I know some might call it just edge, and so on. So instead of hauling all the data back to the cloud to create value, to make sense of it and create value based on that, you have a middle layer which is intelligent, which has all the capabilities of a cloud at a smaller scale, but it can make sense of a lot of data and create some value as well and interact directly with the devices, not just be a mediator, right? So and sometimes sometimes people include devices in the edge sometimes, and some people don't. I think as there's so much of intelligence and processing and especially AI and other things happening on the device side, I think it should be part of the cloud as well. For me, it is the edge cloud or this middle layer. It is the devices and the connection between them, because they have to be intelligent and adaptive to based on what's happening. So together all is edge cloud in my view. And actually, frankly, even there are a lot of versions of the name itself as well, not just views. Some call it edge cloud, some call it mobile edge or mobile edge cloud. In 2017, I think Etsy came up with this acronym called multi-access cloud, MAC. Before that, people used to call it mobile edge cloud, MAC. So, although the acronym remains the same across two aisles, but the definition and the expansion itself is different. Some might call it distributed cloud, distributed computing, you name it, there are tons of names, but in most of the cases, they all mean the same thing, which is what I talked about. No matter what you call it, it is very clear from the industry trends that the value and a lot of intelligence is moving towards the edge of the network. It used to be all reside in the cloud, in the centralized cloud. Now it is moving away from the cloud and towards the edge of the network, towards the devices, toward the edge cloud, And not that doesn't mean that cloud will not do anything. A lot of meta learning at a very high level processing, which is not latency sensitive, will still happen there. But edge is where if you need in terms of application and services need immediate processing, immediate intelligence, and so on, that will happen at the edge cloud or the edge. Um, and also it is intelligent in the sense that instead of just hauling all the data to the cloud, which is expensive and time consuming, why not we process it where it is close to where it is generated and where it makes sense, where actions are taken based on that data, right? So, and there are a lot of other privacy and own data ownership and other issues concerned as well. And the third point is this is extremely relevant to enterprises, especially when you're looking at companies looking at owning their own private networks and so on, and there is data provenance and data ownership, even control ownership in many cases. It makes perfect sense that this edge is owned by enterprises for their own network rather than residing somewhere else on a third party network. So it has a lot of relevance for enterprises for that matter. That doesn't mean there are no consumer applications. There are tons of consumer applications as well. For example, XR, AR, and VR, and you know the term that everybody wants to talk about, and some people are, frankly, including me, tired of talking about metaverse. A lot of that has to work on the edge side. Gaming is another application, especially multi-user gaming where latency is very key. There are many other such applications where consumers benefit from edge cloud and focus on the edge cloud as well. I think it's very telling what a Gartner projected, which basically kind of puts all of this importance of edge in a nice number format. By 2025, they say more than 50% of the enterprise managed data will be created, processed outside the data center or the cloud. So, and all of that is happening in the edge, right? So, it indeed is very important for enterprises. So, what is needed for edge? Obviously, if it is edge compute, as it's sometimes called, it obviously needs compute, but it's not just compute, regular compute that you would have it at the cloud side, but it is a specific type of a compute. To start with, it needs highly reliable connectivity. So it's not, usually if you look at, for example, wireless used to be best effort, and it used to be not deterministic. But if you're looking at edge cloud or edge compute kind of a deployment, you need highly reliable connectivity, which meets the industrial needs like 4 or 5 nines, as they're called, of reliability in terms of, in terms of how reliable, if you're sending a packet each ways, how reliable that can be transmitted and received by the other end. And it is ultra low latency. I mean, this is the kind of a highly abused term, I would say. It's thrown around all in all kinds of contexts, but really the latency, which can be defined as retentive latency, including the application, including the processing latency and everything. So for me, latency is the latency experienced by the end user, which includes the processing on the device itself, includes the connectivity latency, include the processing at the network edge or the edge cloud, and in some cases might include the cloud as well, right? So making sure that you not only provide low latency, but provide the exact latency that is provided by the application or the service that you're trying to use at the edge or on the devices. And third point is extreme capacity. It is the ability to connect and manage millions and millions of devices. It could be going into billions as we move forward, making sure we efficiently manage those and have enough capacity to provide the right quality of service and quality of experience, as it is becoming more important as we move forward. and also for industrial applications and enterprise applications, they write SLAs that companies sign and adhere to. So companies have to be sure before they sign those SLAs that they have a system in place can most of the time attain that level of service that they are contracting themselves to offer. So that's where the reliability comes into picture as well. So it's all on the networking side and the processing side, but you also need extremely power efficient compute. So it can't be the compute that you put in the cloud where we have the luxury of and power, luxury of space, luxury of thermal dissipation, and so on that you can manage. But when you're looking at edge cloud deployments, they are highly constrained in terms of the power they can use, in terms of energy they can use, the power they can dissipate in terms of thermal energy, in terms of space, because a lot of times they're crammed in a cell site, for example, somewhere. So when you're considering all of that, the compute has to be extremely power efficient, and that compute should include AI/ML as well. I mean, AI/ML in edge cloud is a big topic on its own. We can spend hours and hours talking about it. I'll not talk too much about it. I'm just mentioning here that AI/ML is part of that very efficient compute that happens at the edge, right? So, and then it's these are the four vectors, I would say. There are many others, but these are the four main vectors that define edge, that allow you to provide the things that are expected from the edge. But it's not just offering all of them at the best possible way, but ability to scale across these vectors. For example, some applications might need extremely high reliability, but they may not need huge amount of capacity. I mean, if you have to be at the peak of all of these vectors, then you will end up lots of money in terms of implementing those things and deploying those things. So which may or may not be cost effective for the applications that you're running. But the ability to scale them, and some applications might need huge, like IoT and sensors, need huge amount of capacity, but they may not need that kind of extremely low latency. Some applications might need that and not. So the whole idea is you scale the network with the same common network across these vectors to provide cost effective connectivity and compute that is needed for that specific type of service or application, right? That's kind of what is the key to providing a good edge. And edge computing is poised for a tremendous growth. I mean, we're talking about it because it has huge potential for growth across the industries. The numbers that the analysts come up with vary depending on what they consider, how they look at it, and so on. But what is common is all of them show this hockey stick kind of growth that are shown here. I'm using a report from KBV Research. It shows the growth of software, hardware, and services in edge computing till 2027. Going to multiple billions of dollars. So although the numbers vary between all of these reports, but what the two things common? One, as I said, this hockey stick growth, and second, all these are in tens of $million of business opportunity in mid or end of 2020. So some go till 2030, which is a little bit higher than what is shown here. It's 16 billion, 17 billion. But no matter what, it is across the board considered as a great growth opportunity for the companies to be in. And many verticals are already benefiting from edge computing. This is from Garden View Research. According to their calculations in 2021, this is financial 2021, the market was already close to $2 billion. And then you can see the different verticals that are utilizing edge computing and creating value already. And as you can notice, large portions of this pie chart are in IT and telecom, and data center has a big piece as well. I expect this to change a little bit as we move forward, where there is more focus on the smart cities, IoT, and energy utilities, automotives, and so on, not so much on data centers themselves in terms of edge computing. But no matter what, all of these verticals, they grow in size and in market size and in applications and the services they provide. Uh, but some might be more than others, and I suspect a lot of the smart cities, IoT, and other things, as 5G and later parts of latest evolutions of Wi-Fi come into foray into enterprise. Some of the things that we as an industry need to ponder in terms of edge computing and edge cloud, telco versus cloud ecosystem. So they used to be separate. Telcos, I mean, the traditional telco cloud is cloud, including IT infrastructure, but edge computing where these two ecosystems either merge or collide or compete. You decide what term you use, but they have to collaborate and they are coming into interworking with each other. Right now, it is primarily driven by telco ecosystems because operators are the one offering it. But I think cloud players being big as they are, I suspect it will not be the same in the future. They want to play a bigger role and drive this market as well. We will see how that progresses, but there's something that you have to keep in mind. And this multi-cloud and multi-operator evolution. What do I mean by that? If you look at the cloud, edge cloud deployments today, a lot of them are one-to-one, which means you have an operator working with, say, one cloud provider, and the second operator provider with a different cloud provider. That is problematic if you are an enterprise. If your cloud provider is different than the cloud provider that the operator that you work with, then there are a lot of complications and you make things work. At the same time, um, you might have multiple operators with the cloud same provider, but and you only one cloud provider is operating with one operator, then you have complications there as well. So, in my view, it has to be multi-cloud and multi-operator kind of a deployment, and that also is complicated. Which means that in a Verizon base station, you might have a cloud box from say Google, AWS, and Microsoft, and usually have these cloud boxes in one maybe for tens of sites. Then having repeating the same things may not be very efficient, but we as industry we have to come with a better solution. So this private, public, and hybrid networks, things are a little bit clear. If you have a public network, then you're fully relying on the operator. If you have private network, you can define what cloud provider you need and so on. So things are a little bit easier. But if you have a hybrid network, if you, for example, take a multinational, corporate which has presence multiple in multiple countries, then it becomes problematic as well. And the classic public versus private cloud. Again, if you have private network, it's much easier, but if you have hybrid network, juggling between these could be a major issue as well, right? So that's kind of the things that we have to keep in mind when we look at cloud, edge cloud, no matter what you want to call it. So with that, let me stop at that. And if you want to connect with Tantra Analyst, there are some of the ways. As I mentioned, I have a podcast, the website, and Twitter and LinkedIn handle where I'm very active at. And if you have any questions or problem with what I'm saying here, feel free to reach me out. Hopefully, I'll be able to clarify. With that, thank you, Peter. Do you have any time for question and answers, or we are done? Peter, I think you're on mute.
We are coming right up against our deadline, Prakash. So I think with that, we will plant a flag in it. But thank you very much for your insights today. This has been very helpful, and thank you for participating in our event.
Perfect. So, sorry, we couldn't take any questions, but if you have any questions or want to contradict or want to contest what I've said, feel free to reach me out. I'll definitely respond to you guys. Thanks. Thanks, Peter, for hosting me on for this session.
Take care.